Established in 1935, CCL is a trusted specialist in post-tensioned concrete technology. The company has successfully designed, supplied and installed millions of square meters of post-tension slabs in structures across the world. With the growing demand for more cost-effective, flexible and sustainable construction, CCL slabs are increasingly popular with engineers, contractors, architects and their clients. The CCL technique overcomes the natural weakness of concrete in tension and exploits its exceptional resistance under compressive stresses. High-strength steel strands are fed through ducts and then tensioned, creating a compressive, strengthening force in the concrete. CCL slabs offer a thinner alternative to conventional reinforced concrete and use less component material. They allow far greater design flexibility, as well as improving sustainability, build time and cost efficiency for construction projects such as residential and commercial buildings, shopping malls, hospitals, schools, stadia, car parks and transfer structures. The entire post-tensioning process must be carried out by qualified personnel in full accordance with strict health and safety regulations, quality standards and proven methodology. It's always important to select a post-tensioning partner who can provide sound and reliable scheme design and value engineering advice. CCL is comprehensively qualified, proficient and experienced in all post-tensioning matters, and can guide you in every aspect of the process, including design, detailing, system and equipment supply and installation. The first step involves installing the tendons. The strand is delivered to site either in coils or cut to length. To create the tendons, anchorage points are marked, the side shutters or formwork are cut, and the live or stressing anchorages are fixed. A pocket former, made either from polystyrene or reusable plastic, is fitted between the anchor and edge board. This will create a recess in the cast concrete to allow the installation of the anchor head and wedges. Anti-burst reinforcement around the anchor confines and strengthens the surrounding concrete. The ducts are then laid out onto the formwork, connected together and sealed. A trained post-tensioning installer feeds the strands through the ducts either mechanically or by hand, while a second monitors the protruding strand's length at the opposite end. Depending on tendon length, this opposite end may have a live or dead-end anchorage. The basket dead-end anchorage is created by feeding the strand into a jack to form a rigid onion or basket. The tendons are then fixed into position, supported by duct chairs, to achieve the required profile shown on the CCL drawings. By curving or profiling the tendons to the specified design, upward forces are exerted on the final concrete slab in the span region. These forces counteract the loads applied by gravity. Downward forces are exerted over column locations. Accurate profiling and spacing of the tendons is critical and must be carefully checked. Grout vents are then installed according to the specification. The vent tubes protrude well beyond the surface of the concrete so that no debris or water can enter. The post-tensioning installation must be measured, inspected and approved throughout the process. This program is managed meticulously, and CCL ensures close communication between the site and the main offices throughout the entire process. Once the post-tensioning layout is prepared, the whole installation is carefully inspected to check that tendons are properly installed and fully secure. Only when pre-pour inspection sheets and certificates have been issued should the concrete be poured. A pour watcher diligently monitors the concreting process to ensure no damage occurs to the CCL system. When the concrete achieves sufficient strength, the side shutters are removed and the anchor heads and wedges are installed at the live end. A datum is then obtained for each strand before the stressing process can begin. The stressing stage is checked and monitored in particular detail. Rigorous inspection ensures that the process is not only safe, but also that tendons are delivering the correct design loads. Before the stressing can take place, the work area is isolated and only authorized personnel may gain access. The calibrated and certified equipment is given a final check. Once the concrete has reached the appropriate strength and approval is given, the stressing process can begin. If specified by the designer, an initial stress may be applied to induce an anti-crack force in the concrete. Typically between 48 and 72 hours after the pouring, and when the concrete in the slab has reached the required design strength, the final stressing takes place. Following a prescribed sequence, each individual strand is stressed in a single smooth action and is then locked off. The extended length of each strand is measured and recorded against the initial datum. When the stressing is complete, all extension records are checked by the engineer. Only with his approval can the strands be cut. The pockets are then dry packed or filled with a non-shrink mortar, and the tendons are identified before grouting takes place. Grouting protects the post-tension strands against corrosion and creates a bond between the tendon and the concrete. Each tendon is first air tested by blowing compressed air through the ducts to ensure the grout can flow freely. The results for each tendon are recorded and checked before grouting begins. The grout is prepared to a specified cement-to-water ratio using calibrated equipment. Grout temperature is regulated and checked using a probe thermometer. The tendon or member temperature must be above 3 degrees Celsius, otherwise special cold weather procedures can be implemented. Tests are then carried out to check grout fluidity. A wick test confirms bleed levels and volume change, and during the grouting process, grout specimens are formed and sent for independent testing to verify their strength. Wherever the method statement or specification requires it, the fluidity test may be repeated. When all checks are satisfactorily completed, the grout hose is connected to the injection vent and the grout is pumped into the duct. Once the grout flows from the exit vents, they are sealed off. The tendon is then pressurized in line with the project specifications and the grouting documents are completed. At least 1 day after grouting, each grout vent is checked to make sure that grout is still present. Only then can the plastic grout vent tubes be removed. The CCL slab is now complete, and the client receives a comprehensive set of documents confirming the quality and standards of the process. The benefits of high-quality post-tensioning are increasingly valuable to the construction industry, to clients and users, and to the quest for greater sustainability. Thinner slabs reduce the quantities of concrete and reinforcement required, allowing for lighter structure. They can also reduce building height or accommodate additional floors within the same building envelope. CCL slabs can span further than traditional reinforced concrete, meaning fewer columns for more spacious and flexible interiors. Uplift forces applied at mid-span deliver enhanced deflection control. Greater crack resistance gives CCL slabs a durable, low-maintenance finish, which is ideal for exposed soffits. Free routing of mechanical and electrical services reduces MEP costs. Construction is faster because times for fixing, pouring and formwork removal are significantly reduced. Sustainability matters. The reduction in the amount of materials used, and therefore also deliveries to site, gives post-tensioned concrete a smaller carbon footprint. Exploiting thermal mass with exposed soffits can further shrink a building's ongoing operational energy costs. Last, but most definitely not least, CCL slabs can generate excellent cost savings because of lower material costs and faster construction schedules. With our world-class expertise, the CCL team is perfectly placed to help your organization take full advantage of this versatile, cost-effective and sustainable technology. To learn more or to discuss your latest project, please visit our website